In the world of mathematics, where numbers dance and equations weave intricate patterns, there exists a fundamental rule that guides every computation, every problem-solving endeavor, which is the order of operations. This seemingly simple set of rules dictates how we should evaluate mathematical expressions, ensuring consistency and accuracy in our calculations. From the humble arithmetic of elementary school to the sophisticated equations of advanced calculus, the order of operations remains an indispensable tool for mathematicians and students alike. So, what exactly is the order of operations, and why is it so important? Let's delve into the intricacies of this mathematical principle to unravel its significance. At its core, the order of operations provides a standardized sequence for performing mathematical operations within an expression. It serves as a roadmap guiding us through the maze of numbers, variables, and symbols, ensuring that we arrive at the correct solution every time. Without this guiding principle, mathematical expressions would be subject to ambiguity and confusion, leading to inconsistent results and mathematical chaos. The order of operations consists of a set of rules that dictate the sequence in which various mathematical operations should be performed. These operations include addition, subtraction, multiplication, division, exponentiation, and grouping symbols such as parentheses. By adhering to these rules, mathematicians can avoid misunderstandings and ensure that everyone arrives at the same answer when evaluating a given expression. The mnemonic device PEMDAS is often used to remember the order of operations. Parentheses, exponents, multiplication and division from left to right, addition and subtraction from left to right. Let's break down each component of PEMDAS to understand its roles in the order of operations. First, parentheses. The innermost operations within parentheses are evaluated first. Parentheses are used to denote priority, allowing us to isolate parts of an expression and perform operations within them before moving on to the rest of the expression. This enables us to clarify the order in which operations should be performed and override the default order dictated by PEMDAS if necessary. Second is exponents. Once all parentheses have been simplified, exponents are evaluated next. An exponent indicates the number of times a base should be multiplied by itself. By resolving exponents according to the order of operations, we can efficiently compute expressions involving powers and roots. Our next step, we have multiplication and division. After evaluating parentheses and exponents, we move on to multiplication and division, performing these operations from left to right. Multiplication and division have equal precedence, and are evaluated in the order they appear in the expression. This ensures consistency and eliminates ambiguity when dealing with multiple multiplication and division operations within an expression. Addition and subtraction. Finally, we evaluate addition and subtraction, again proceeding from left to right. Like multiplication and division, addition and subtraction have equal precedence and are performed in the order they appear. By following this sequence, we can systematically compute the final result of the expression. It is important to note that within each level of the order of operations, operations are performed from left to right. This left to right evaluation ensures that expressions are evaluated consistently regardless of their complexity. Let's illustrate the importance of the order of operations with a simple example. Consider the expression 3 plus 4 times 2. Without adhering to the order of operations, one might be tempted to simply perform the addition first, resulting in 7 times 2, which is 14. However, by following PEMDAS, we recognize that multiplication takes precedence over addition. Thus, the correct evaluation is 3 plus the quantity of 4 times 2, which gives us 3 plus 8 is equal to 11. This example demonstrates how adhering to the order of operations ensures accurate results. Moreover, the order of operations extends beyond basic arithmetic to encompass more complex mathematical concepts. In algebra, for instance, expressions involving variables follow the same principles as numerical expressions. By applying the order of operations consistently, mathematicians can manipulate algebraic expressions, solve equations, and unravel the mysteries of abstract mathematical structures. Furthermore, the order of operations is foundational to calculus, where precise computations are essential for analyzing functions, calculating derivatives, and integrating functions. In calculus, understanding the proper sequence of operations is crucial for unraveling the intricate relationships between variables and functions, enabling mathematicians to model real-world phenomena and solve complex problems in fields such as physics, engineering, and economics. In conclusion, the order of operations is a cornerstone of mathematics, providing a systematic framework for evaluating mathematical expressions with precision and consistency. By following the rules outlined by PEMDAS, mathematicians can navigate the labyrinth of numbers and symbols, arriving at accurate solutions and uncovering the beauty of mathematical truths. Whether tackling simple arithmetic or exploring the depths of calculus, the order of operations remains an indispensable tool, guiding our mathematical journey and shaping our understanding of the universe.